So let's start with the construction part of the power diode. Power semiconductor diode are similar to low power PN junction diode. That low power PN junction diode called as the or known as the signal diode. But power semiconductor devices are more complex in structure and in operation than their low power semiconductor devices. How? See, this complexity arises because low power devices must be modified in order to make them suitable for high power applications. For example, let's take the example of the power semiconductor diode. So the symbol of the signal diode is this, and the symbol of the power diode is this. They both are similar from the symbolic view. Then how they differ from structural view? Let me show you. The structural view of the signal diode is like this. There is one p layer and then one n layer. Then this terminal is called as anode. This terminal is called as cathode. Then how the power diode differ from the signal diode? See this structural view. Here there is one p plus layer, there is one n minus layer, there is one n plus layer. So in this case n minus layer is sandwiched between p plus layer and n plus layer. So what do you mean by this p plus and n minus and n plus? So in power diode, this n minus layer is sandwiched between p plus and n plus layer. This n minus layer is called as the drift layer, or this space is the drift space. Okay, so what is the need of this drift space? This drift space is used to absorb the forward voltage drop and is also used to reduce the depletion layer, or it is also used to absorb the depletion layer and is also used to reduce the voltage drop during the reverse bias operation of the power diode. So now you just see how you differentiate the p layer, p plus layer, n layer, n minus layer, n plus layer. What is the meaning of this p, p plus, p minus, n plus, n minus? See, this comes from the doping point of view, from the label of doping. What do you mean by doping? See, you already know that the semiconductor materials are of two types, intrinsic and extrinsic semiconductor type. Intrinsic semiconductor material is the pure semiconductor material. So when we add some impurity into the in the pure semiconductor material, then it is formed like a p type material or n type material. How? When we add trivalent impurity to intrinsic type semiconductor material, then it form a p-type semiconducting material. So this the addition of this trivalent impurity is your acceptor atoms. Okay, so and similarly when we add pentavalent impurity to the pure semiconductor material, then it will form n-type semiconductor. So now you got it, p-type and n-type semiconductor material. So from where p plus, p minus, n plus, n minus comes. So p plus means heavily doped p layer. Heavily doped means here the doping level is 10 to the power 19 atoms per cm cube. Similarly, n plus means it is also heavily doping n layer. Here also the doping level is 10 to the power 19 atoms per cm cube. So, and n minus means lightly doped n layer. Here the doping level is 10 to the power 14 atoms per cm cube. So p, in the case of pure, the doping atom is the acceptor atom, and in case of n type material, the doping atom is the donor atom. For P type, in the P type, the doping atom is the acceptor atoms, and for N type, the doping atom is the donor atoms. Okay, now you got the in the P plus or P minus or N plus or N minus. What are the difference between these P plus, P minus, N plus, N minus? Now you got it. Okay. So now you understand this constructional structure of the power semiconductor diode. The power diode is the structure is like the three layer, that is P plus, N minus, and N plus substrate layer. These three layers, from these three layers there is one PN junction and two terminals, that the anode terminal connected with the P plus layer, and the cathode terminal contact or connected through this metallic layer with the N plus layer. So in case of signal diode, there is also P layer, N layer, and there is two terminal, one PN junction, that is anode, cathode, PN junction. And in case of power diode, there is three layer, one PN junction, and two terminal, that is anode, cathode. Okay, so clearly understood about the structural difference between the signal diode and power diode, and why the structure, from the structure point of view, the power diode is different from the signal diode. Now you understand the structural complexity is only due to what? It is only due to the N minus layer is for only for the purpose of the absorption of the depletion layer and absorption of the forward voltage drop during the reverse bias conduction of the power diode. Okay, so and also by simplify the structure of this diode, we can able to make the diode to operate or to use in the high power level application, whereas the signal diode is not able to use in the high power application. Signal diode are for only the low power application, and power diode are for only for the high power application. The main difference is the signal diode for the low power level, and the power diode is for the high power level. Okay.